Hi, let's discuss LL1 parsing process using stack. In LL1 parsing first lecture, I discussed a block diagram of LL1 parsing. There was a parsing algorithm and there was a parsing table, a parsing stack and some input string. We already discussed how to construct parsing table. Now we'll check how parsing algorithm can verify that this input string can be accepted by this parsing stack or not using this parsing table. Input string that will be end with dollar, parsing stack that will be start with dollar, and parsing algorithm check from the parsing table that which production to use if there are more than one production. Let's first discuss this step, then I'll explain with example. First step, push the start symbol of the grammar into the stack. Second, compare the topmost symbol of the stack to the look ahead symbol. Third step, if matching occur, then pop off and increment the pointer. Matching occur means x equal to a equal to dollar. X is the stack topmost symbol, a is the current input symbol, and dollar that is the end marker and stack bottom symbol. Next, step 4. If matching doesn't occur, then perform the push operation again and compare top of the stack with look ahead symbol. Matching doesn't occur means x is not equal to a. Then fifth step, after reading complete string, if stack is empty, means x equal to a equal to dollar, then parsing is successful. Here x is the top of the stack symbol, a is the current input symbol and dollar is the end marker. Let's discuss with the example. Here grammar is s derived start bracket s end bracket or epsilon, and a string we consider start bracket end bracket. We already constructed parsing table for this. Just I'm writing the parsing table. You can go through that video of how to construct parsing table and we'll use a stack for this. Now what is the input string is given? Input string is given start bracket, end bracket, and it will be end with dollar. This is the input string and we need to check by using parsing table and on stack whether it is accepting or not. Initial input pointer will be here. We'll make three columns. One is for stack, one is for input string, another is for action. There will be two action, either it will be push or it will be pop. Initially stack contain dollar, then input string contain start bracket, end bracket dollar. And what should be the first step? First step should be push the start symbol of the grammar onto the stack. Here what is the start symbol? That is S. So action is push S. This action will do in next step. So in next step we'll push S. So this is a stack. We'll push S onto the stack. Now just check top of the stack is matching with the input pointer is not. This is our X. This is our A. Is X is matching with A? Here S and here is start bracket. So it is not matching. When matching doesn't occur, then perform the push operation. Now for variable S and input symbol start bracket, which production we should use? There are two production. Now just check in parsing table. Variable is S and input symbol is start bracket. So we should use this production. So what will be action? Action will be push S derived start bracket S end bracket. Now how we'll push this onto the stack? First we'll push this symbol, means first we'll push end bracket, then we'll push S, then we'll push start bracket. So this symbol can be at top. This start bracket can be at top and it will match with the input string. We are pushing in a reverse way. First the end symbol, then the middle one, then the first symbol. Now what is stack content? Stack content is end bracket, S, start bracket, and input pointer that is pointing to this start bracket. Now whether it is matching, here stack topmost symbol is start bracket and input pointer is start bracket. When matching occur, we should pop off and increment. It is step 3. Now matching occur, start bracket, here is also start bracket. So we should pop this symbol from the stack and will increment the input pointer. Now what is the stack content? It is end bracket S and input symbol is pointing to this start bracket. Topmost stack symbol is S and here is start bracket. Matching doesn't occur. So for variable S and start bracket, which production we should use? We should use this production. according to parse table. So in place of S, you just push end bracket S and start bracket. That you have written in action. In next step, what will be stack content? Stack content will be to end bracket S and start bracket, and pointer is pointing to this. Now whether it is matching, topmost stack symbol is start bracket, here also start bracket, it is matching. When matching occur, we will pop this and will increment the pointer. Now what will be stack content? Stack content will be end bracket and S. And what will be input string? Input string will be end bracket and dollar. Now just check, is it matching S and end bracket? It doesn't match. So for S and end bracket, which production we should use? Now variable is S and input pointer is pointing to end bracket. So the production we should use is S derive epsilon. Now here push S derive epsilon. Epsilon push means it is just pop. We'll simply pop this S. Now what will be stack content? Stack content will be to end bracket. Now just match. Here top of the stack symbol is end bracket. Here pointer is pointing to end bracket. It is matching. So we'll pop up. We'll pop up this end bracket and we'll increment the input pointer. Now what will be stack content? Stack content will be one end bracket and input string will be one end bracket. Now also it is matching. Top of the stack is end bracket. Input pointer is pointing to end bracket. It is matching. So we'll simply pop it and we'll increment the input pointer. Now what stack content? Stack content simply a dollar. Just write down dollar. And input pointer is pointing to simply dollar. Just write down dollar. This is step 5. If matching occur, x equal to a equal to dollar, then it should accept and parsing is successful. Means this string is part of this grammar. We just check by parsing stack and parsing table. And here one question can be asked, number of push operation. If it is asking number of push operation, then it will be 4. If it is asking number of different push operation, it will be 3. This will be 1, this will be 2, this will be 3. These two are same push operation. So number of different push operation will be 3. In this grammar there was epsilon, so we got number of different push operation is 3. If there will be no epsilon, then number of push operation will be length of this string. Here length of the string is 4, so number of push operation will be 4 if there is no epsilon. Let's see another grammar without epsilon. Here grammar is S derive A derive AA or B, and a string we consider AB. We already constructed parse table for this, just go through that lecture. This is the parse table. We need a stack. Now we'll check this input string. So what is the input string given? AB, that will be end with dollar. So initially stack content is dollar and input string is AB, and we already have a parse table. In block diagram we discussed there was 3 component. One was input string, one was parsing table and one was parsing stack. There will be 3 column, one is for stack, one is for input string, another is for action. Now what stack content? Stack content the dollar and input string content AB dollar. So first step should be push the start symbol. Now we'll push this S onto the stack and input pointer is pointing to the first symbol of the string. Now stack contain S. Now just match whether this S match with A. No, we should push. Now for variable S and input A, which production we should use? We should use this production S derive AA. Just write down S derive AA. We'll push this onto the stack. So next step stack content will be AA and input string content AB dollar. Now topmost stack symbol is A and input pointer is pointing to A. So whether this lookahead symbol is matching with topmost stack symbol? No. When it is not matching, we should push. Now for variable A and terminal A, which production we should use? We should use this production A derive AA. And how we'll push it onto the stack? We'll push in reverse way. First we'll push this A, then we'll push this way. So first we'll push this A, then we'll push the terminal A. Now what is the stack content? Stack content is A and lookahead symbol pointing to A. Now just try to match whether it is matching. Topmost stack symbol is A and input pointer is pointing to A. So when it is matching, we simply pop it and we will increment the pointer. Now stack contain AA and pointer is pointing to B. Whether this is a match, this A is matching with terminal B? No. If it doesn't match, then we should push. Now which production we should push? For variable A and terminal B, we should push A derive B. Now just push A derive B. In place of this E, we'll push B. Now stack contain A, B and pointer is pointing to B. Now just try to match this B with this B. It is a match. When matching occur, we simply pop it and we'll increment the pointer. Now stack contain A and pointer is pointing to terminal A. Now just try to match. Is it matching this topmost stack symbol A with terminal A? No. Then we should push. So which production we should push? For A variable terminal A, we should push this production A derive AA. Now just try down push A derive AA. This thing we'll do in next step. Now we'll push AA. We are pushing in reverse way. First we'll push variable A, then we'll push the terminal A. Now stack contain AA and look at symbol pointing to A. Is it a matching? Topmost stack symbol A. Here is also A. It is a matching. So what we'll do? We'll pop topmost stack symbol and we'll increment the pointer. Now stack contain A and pointer is pointing to B. Now just check is it matching? Here variable A, here terminal B. Now for variable A and terminal B, which production we should use? We should use A derive B. Just try down push A derive B. That will push in next step. Now stack contain terminal B and pointer is also pointing to B. It is a match. When matching occur, we simply pop and we'll increment the pointer. Now stack contain dollar and input pointer is also pointing to dollar, so it is accept. This is the step 5. If both X and A contain dollar, then parsing is successful. So what are the steps? First step, we are pushing start symbol onto the stack. Then we are trying to match with the input string. If matching occur, then pop. If matching doesn't occur, then push. So which production will push? That is according to the parse table. Simply we are doing two operations. One is push, another is pop. When matching doesn't occur, we are pushing. When matching occur, we are popping. If both contain dollar, then it will accept. Now here number of push operation 1. This is 2, this is 3, this is 4. This is a repetition, this is a repetition. So number of different push operation is 4. There is no epsilon, so you can normalize it. Minimum number of distinct push operation is n without epsilon production. If there is epsilon production, then it will be n minus 1. You can remember the previous example, their string length was 4, but we got 3 push operation. In case of epsilon production, number of push operation will be n minus 1. If there is no epsilon, then it will be minimum n. In next lecture, I will start bottom of parser. If this lecture is helpful for you, please like and subscribe. Thank you.